So in this lesson, we'll chat about hazard. Thus far, we've looked at survival models where we've had the question, what is the probability of survival past any time t? And to answer this question, we saw the survival function, which tells us the probability that the time to an event is after some time t, and we could represent the survival function graphically with time on the x-axis, which we'll call t, and on the y-axis, the survival probability, which starts off at 1 and then goes to 0 as time goes on. But let's say we were interested in now a different question, not what the probability of survival past any time t is, but what a patient's immediate risk of death is if they make it to some time t. And we might want to know this to understand whether a patient is more at risk in year 1 or in year 10. And we can use this information to then inform treatment when the patient is most at risk. So how do we represent a patient's immediate risk of death if they make it to time t? So this is what's called the hazard. And the hazard is represented by the Greek letter small lambda. And the hazard of t is the probability that the time to an event is at t given it is at or after t. And the interpretation of this is, what is the risk of death if someone is aged t? What is their immediate risk of death if they make it to time t? And that's what the hazard is. And like the survival function, the hazard function can be represented graphically. So once again, we have t on the x-axis, and now we have small lambda t on the y-axis, and it's telling us as time goes on, what is our hazard at that particular time. So notice from the shape, we can tell what a patient's hazard is, what a patient's instantaneous risk of death is at any point in time. We can see that it's highest at 0 and then drops rapidly to 4 and then increases again to the time of 10, where it's getting to a similar hazard as a time of 0. And so this allows us to see that the patient's risk is high in this area, not so high in this area, and again growing later. And this is what's called a bathtub curve, where the risk of death is very high immediately at time 0 and then goes down and then increases with time. And this can happen, let's say, with some treatment like surgery, where the risk of complications immediately might be very high, but then they go down over time, but then the patient's risk increases as time goes on.